By early 1970, walking on the moon had started to look like a walk in the park. The public's interest in lunar missions had dropped off so much that major television networks declined to broadcast the crew's live feed from space. High above the Earth, the three-man crew of Apollo 13 was cruising smoothly toward the lunar surface in the command module. They were traveling at roughly 40,000 kilometers per hour, nearly 200,000 miles from home. The flight was so routine that at 46 hours into the mission, the capsule communicator back in Houston famously radioed up a joke, telling the crew they were bored to tears down on the ground. At 55 hours and 46 minutes, an astronaut threw a switch to stir the oxygen tanks inside the service module. In the dark mechanical void, cracked wires were suddenly exposed to highly flammable oxygen. A spark ignited, and tank number 2 violently exploded. Master alarms blared through the cabin. A glance at the window confirmed the worst. Pressurized oxygen was visibly venting out into the vacuum of space. Within minutes, 2 of 3 fuel cells died, wiping out the primary source of electricity. The moon landing was instantly scrubbed. The astronauts were now trapped inside a rapidly dying ship, moving away from Earth at high speed. The engineering challenge immediately shifted. The ground team and the crew had to figure out how to stretch a rapidly depleting supply of oxygen, water, and power to survive the lethal conditions of deep space. With only 15 minutes of power left in the crippled command module, the crew had to shut down its systems to conserve the batteries. They crawled into the lunar module to use it as a lifeboat. The math was terrifying. The lunar module's aluminum skin was only 12 thousandths of an inch thick, barely 3 layers of kitchen foil. It was engineered to keep 2 men alive for 2 days on the lunar surface. Now, it had to support 3 men for 4 straight days. The explosion had also knocked the ship completely off course. If they failed to correct their trajectory, they would loop around the moon and completely miss Earth on the return trip. To return, they'd execute a slingshot maneuver, using the moon's gravity to fling the spacecraft around the far side and accelerate back toward Earth. But this was dangerous. The dead command module skewed their center of gravity, and the primary navigation computers were turned off. To correct their course without computer guidance, the crew performed a manual 14-second engine burn. They literally looked out the window and used hand controllers to keep the distant image of Earth centered in the physical glass frame to steer. Once the ship was pointed home, a quiet biological threat emerged. Every exhale produced by the 3 men filled the tiny cabin with toxic carbon dioxide, and the lunar module's air scrubbers were running out. As you can see in this illustration, the crew faced a geometric incompatibility. The disabled command module had plenty of spare CO2 filters, but they were square. The lunar module's receptacle only accepted round canisters. Engineers on the ground designed an adapter using only the materials the crew had on board. They radioed up the instructions, and the astronauts successfully built the contraption using plastic bags, cardboard, and duct tape. The physical toll mounted rapidly. The cabin temperature dropped below freezing. Water was strictly rationed, leaving the crew severely dehydrated. Under these conditions, lunar module pilot Fred Hayes developed a bladder infection and a violent fever. Survival required the engineers and the astronauts to deliberately strip down, reverse engineer, and misuse their own multi-million-dollar hardware just to secure a few extra hours of life support. Approaching Earth, the crew faced their final hurdle: discarding their lifeboat and surviving atmospheric re-entry. They had to hit a precise 2-degree wide wedge in the atmosphere. Shallower than 5.5 degrees, the capsule skips out. Steeper than 7.5 degrees, they burn up as a fiery meteor. The crew transferred back into the freezing command module. They attempted a desperate cold boot of the batteries, hoping the extreme sub-zero temperatures hadn't shattered the electronics or the vital heat shield on the bottom of the craft. A moment of relief came when the switches were thrown and the control panels booted up. The components held together. The crew jettisoned the shattered service module, and finally their lunar module lifeboat. The flight hit the Earth's atmosphere, triggering the expected communications blackout caused by the plasma envelope. The silence was only supposed to last 3 minutes. When those 3 minutes passed without a SINMO, the monitoring engineers grew terrified that the heat shield had failed. Then a voice broke through the static. The crew was alive, and the parachutes had successfully deployed in the sky. After 142 hours of near-death survival, the capsule safely splashed down in the Pacific Ocean. Investigators eventually discovered the root cause of the explosion. A voltage update to a tank heater had been implemented without upgrading the corresponding thermostatic switches. A routine pre-flight test on the ground then damaged the Teflon insulation on the internal wires, creating a microscopic short circuit. Apollo 13 didn't achieve its primary goal of landing on the lunar surface, but the safe return of the crew proved that rigorous system design, brilliant improvisation, and sheer human grit can outsmart the unforgiving hostility of space.